Hi, hello students, good evening everyone. I hope all are doing well. Anyway, warm welcome all of you to the Infinity Learn JEE YouTube channel by Sri Chaitanya. This is Miss Surya, your chemistry faculty from Infinity Learn. Okay, if anyone watching this particular live, just give me a hi in the comments so that I can identify whether I am audible or not. Okay, we will be moving to the next part of our hydrocarbons. In the last class, we have studied about the first type of hydrocarbons, right? Alkanes, that is the saturated hydrocarbons. We have successfully completed the isomerism, nomenclature and all the physical as well as chemical properties of alkenes. I hope you guys have revised the topics that we have covered in the last class. And today in this particular session, we are going to discuss the next type of hydrocarbons, that is alkenes. Okay, let's get started. What do you mean by alkenes? As we already know about the classification of hydrocarbons, right? We can be classified the hydrocarbons into saturated as well as unsaturated hydrocarbons. In terms of unsaturated hydrocarbons, there will be the first type, that is known as alkenes, right? So, alkenes are the unsaturated hydrocarbons having carbon-carbon double bond, right? Carbon-carbon double bond. So, in terms of name, alkenes are also known as olefins. Olefins means oil forming, right? Oil forming. So if you are taking first member of the alkene group, we can say that it will be ethylene. Let us see the structure also. Ethylene will react with chlorine to form an oil forming substance. So in general, these alkenes are known as olefins or oil forming. Just like that, we have already seen about the alkenes, right? Those alkenes are known as paraffins, but here alkenes are known as olefins. So now let us talk about the general formula of alkene, right? General formula of alkene. It will be given as CnH2n, where n is the number of carbon atoms, 2n is the number of hydrogen atoms. So in terms of alkenes, it was CnH2n plus 2, right? Here 2 hydrogen atoms are less as compared to the alkene because of the double bond. So the general formula for the alkene will be CnH2n. So let us see what is the first member of the alkene group, right? For example, if I am taking n is equal to 1, right? N is equal to 1. What will be the formula? CH2, right? So, we may experience there is a compound having alkene bond, right? Alkene having one carbon atom. This is known as methylene. In general, it has very short life, right? It has very short life. So, we can say that the first member in the alkene group will be n is equal to 2. This formula is known as C2H4, right? C2H4. Otherwise, it is written as CH2 double bond CH2, right? It is known as ethene, right? 2 carbon compound. Then n is equal to 3. C3H6, right? As you can see over here, there is a difference between CH2 molecule, right? Hi Himanshu, good evening. Here is also you can see that there is a difference between 2 alkene group, right? There will be a difference of CH2 molecule. So we can call these particular compounds as a homologous series, right? Homologous series, as we have already seen in the case of alkenes also. Clear? This is the basics about the alkenes or the first unsaturated compounds. Hi Girito, good evening. Is that clear? Let me move to the UPSC nomenclature of alkenes. Now let us talk about the nomenclature, right? We have to name the alkenes just like that alkenes also. Here is a method or the examples of IUPAC nomenclature. Just like alkenes also, we have to do the same thing. First, we have to find out the longest chain, right? Longest chain. For example, if I am taking the first compound here, it is given as CH2 double bond CH2, right? So, as we already know, there will be 2 carbon atoms, right? So, we can call this element as eth. Eth is the word root, right? containing 2 carbon atoms. It will be the word root. Then in the case of alkene, the suffix will be ene, right? Ene. So in the first compound we will be call it as ethene, right? Ethene. Now let us talk about the next compound, right? If I am taking the next compound, CH3. Hi Rana, good evening. CH3, CH double bond, CH2, right? CH3, CH double bond, CH2. So here is also, this is a 3 carbon compound, right? Word root will be prop and alkene. So suffix will be ene. So the name is given as propene. Otherwise you can also mention the position here, right? For example, if I am taking prop, that is the word root, right? Okay, this is the word root prop. Then if I am numbering from here, right? In order to give the IUPAC nomenclature of alkene, first thing you have to do that, find out the numbering, right? Find out the longest chain, then give the numbering in such a way that the double bond must contain least number. Clear? So I am starting from here. 1, 2, 3. So as you can see over here, the double bond is present in the first carbon, right? So I am naming it as prop 1ene. Is that clear? Is that clear? Okay, Himanshu, I will try to speak in Hindi also, fine. Okay, then what about the third compound, right? Here it will be 1, 2, 3, 4, right? 4. Numbering start from the double bond side. So it will be but1ene or butene, right? Clear? Then what will be the name of next compound? CH3, CH double bond, CH, CH3. What is the difference between that? This third and fourth compound, what will be the difference there? The difference in the position of double bond, right? Difference in the position of double bond. So I am starting numbering from here. Okay, this is a symmetrical, so I can start from either from left or right also numbering, right? So second position is having the double bond. So this is a 4 carbon compound. Word root will be but, right? Position of alkene group or the double bond will be second position. So but2ene. Is that clear? Now try to find out the IUPAC name of this particular compound. It is given as C3H7, right? So it will be CH3, CH2, CH2, right? CH2, CH2. So it will in total it will become C3H7, right? Then CH double bond CH2. This will be the expanded structure formula of this particular compound, right? So starting from the numbering in such a way that double bond containing least number, right? So I am starting from here, right? 1, 2, 3, 4, 5. So this is a 5 carbon compound. Word root will be pent, right? Word root will be pent. Position of double bond will be first position, first carbon, right? So pen 1, suffix ene. Clear? Then another example is about the branching, right? Branching. So here also I am expanding the structural formula here. So CH3, right? CH3, CH, there is a branch of methyl group. CH, double bond CH2, right? What you are observing here, this is a 4 carbon compound, right? 4 carbon compound. So word root will be but, right? In order to name the alkene first, if you have any branches, you should name the branch first, right? Along with their position. So starting from the numbering here, right? 1, 2, 3, 4. So that I will get the position of double bond at the first carbon. So but1ene having a methyl group in the third carbon, right? So 3-methyl but1ene will be the IUPAC nomenclature of this particular compound. Clear? Then what about the next compound? When you are expanding this compound, you will get that. I will again write it here. The straight chain, it will be a 4-carbon compound, right? 1, 2, 3, 4. So starting the numbering from the double bond here. 1, 2, 3, 4. So you can see here in the third position of carbon there will be 2 methyl group, right? 2 methyl group. So we have to mention the branching of the particular methyl group here. So it will be 3,3 dimethyl because there will be 2 methyl groups present. So 3,3 dimethyl but, word root will be 4. Word root will be but because 4 carbons are present. Then first position there will be a double bond. Because of the presence of the double bond it will be ene. Is that clear? Okay, fine. Okay, so far we have discussed about the IUPAC nomenclature of alkenes, right? What you have to do first? First find out the longest chain in the alkene, right? Longest chain, then do the numbering. Starting from the numbering where the double bond having least number, right? Maximum it will be 1 or 2, right? Then if you have any branches, you should mention the branch along with their position. Is that clear? This is the main method or the rules to find out the name for alkenes. Now let us talk about the isomerism, right? As we have already seen about the alkenes, saturated hydrocarbons, we have seen 2 types of isomerism. What are they? Have you revised? What are the different types of isomers which is present in the case of alkenes? Okay, first step it will be structural isomerism, right? Structural isomerism, then it will be conformational isomerism. Instead of here, in the case of alkenes, there will be a double bond, right? There will be a double bond. So we can say that there will be structural isomerism also, right? Only difference between the structure but molecular formula will be same. That is the definition of isomers. So here, because of the presence of a double bond, there will be the rotation. There will be the rotation between the double bond, right? So due to the presence of a double bond, this rotation will be restricted here, right? Rotation will be restricted here. Due to the restricted rotation, there will be another isomerism present in the case of alkenes that are known as geometrical isomerism, right? Geometrical isomerism. So when we are discussing about the isomers of alkenes, there will be 2 types. One is structural isomerism and another one is geometrical isomerism. Okay, I hope it was clear. I'm just giving the brief idea about the isomers. Now let us talk about the structural isomerism in detail. Okay, I have already mentioned, right? Structural isomerism means there will be the same molecular formula, but there is a difference between the structures. I'm given the example of butene here, right? Butene, C4H8, 4-carbon compound. 4-carbon compound containing double bond, that is known as C4H8 or butene. What are the different types of isomers or the structural isomers in the case of butene? 4-carbon, right? So I am giving first double bond here, then CH2, CH. Right? This is the one type of compound. Okay, Himanshu, no need to worry. We will be explain the geometrical isomerism in detail. Right? Yes, this trans isomerism, it is a type of geometrical isomerism, right? Okay, this is the first type of compound, straight chain compound, right? So it is known as butene. Then, what is another type of compound? What I have to do? I can just change the position of double bond, right? I can just change the position of double bond. So, right? Another compound, right? Now, the third one I am doing. Right? Okay, so that we will get three different types of isomers here, right? As you are observing here, you can see that the molecular formulas are same, C4H8 in three cases, right? So, what will be the name of the second compound? What will be the name of second compound? Word root will be bute, right? Position of carbon will be in the second position, so it will be double bond will be in the second position, so it will be butene. Then this will be the 2-methyl but-1-ene, right? Or butene. 2-methyl butene, right? 2-methyl butene. So this is the different types of isomers here. So if I am observing here, what I have observing, there is only difference between the position of double bond, right? Position of double bond. So I can call these isomers as the position isomers, right? Position isomers, which means that it has the same molecular formula, but the only difference in that the position of the double bond, right? These are the position isomers. Then what about the second and third? As we already discussed about the alkenes, right? There will be the chain isomers. If any of the compound that is containing branches, it will be known as a chain isomers, right? Difference in the chain. First one it will be the straight chain, here it will be the branched compound. So this is known as the chain isomers. Right? Now next I have a question for you. If I am considering the first, this compound, and the third compound, what type of isomers it will be? Whether it is a chain isomer or the position isomer. Focus the structure completely on the first and third one. Butene and the 2-methyl butene. Is it a chain isomer or the position isomer? Chain, right? Yes, correct. This will be the chain isomers. This is the straight chain. This will be their branch. So it will be chain isomers. So now I hope you get the idea about the structural isomerism, right? Okay. Now I will give a task for you. Take it as an homework to find out the 5 structural isomers of the pentene, right? C5H10 compound. There will be 5 isomers you will get. Try to find out their structural formula, right? Fine. Okay, this type of isomerism is little bit easy. Now let us talk about the geometrical isomerism, right? Geometrical isomerism. So I need your complete attention here. It is little bit, not that much tough, it is little bit tough. If you have the concept or the idea, it will be very easy, right? So I have already mentioned that there is a double bond between alkene, right? There will be a double bond between alkene. So just like alkenes, we cannot do the rotation very easily, right? Because there is a pi bond. You have already know about the how this pi bond is forming, right? There is a sidewise overlapping of p orbitals. I have already mentioned in the chemical bonding chapter. So in the case of alkenes, because of the presence of that pi electron cloud, it is very difficult to difficult for the free rotation. So there will be the rotation is restricted between the carbon-carbon double bond. Because of the restricted rotation, there will be the different arrangement or the spatial arrangement of different atoms, right? So I hope it was clear. Because of the restricted rotation of an atoms or groups around the doubly bonded carbon atoms, there will experience to different geometries. Such type of isomers are known as geometrical isomers. Clear? Geometrical isomers. For example, I am taking the butene, right? In the second position, there is a double bond, so I am taking butene here. Now, I am trying to find out the geometrical isomers of butene here, right? What I have to do first, consider the double bond here, right? So, I am writing here C double bond, right? This is my C double bond. What are the two different groups present in the first carbon atom? What are the two different compounds? I mean, two different atoms or groups present in the first carbon atom. Focus on the first carbon atom only. One is hydrogen, right? And the another one is methyl group. So I am trying to write here. This is our hydrogen. This is our CH3, right? Okay, I will give you a different color to you to understand. Okay, CH3, right? Similarly, in the second carbon atom, same type of groups, right? Hydrogen and CH3. So I am taking here, it will be CH3. Then the next hydrogen, right? It will be hydrogen. So this is my first type, right? Now I am just changing the position here. C double bond C, right? I'm just keeping the first carbon terms here. Okay, what you are observing here in these two different structures, what you are observing here, is there any difference between the structures? If you are focusing on the hydrogen atoms only, right? These are the same group, identical groups, right? These identical groups are on the same side of the double bond, right? Is it not clear? Because of the language issue. Okay, fine. Okay, here in this case of hydrogen, right? If I am considering these two hydrogen atoms, it is on the same side, right? Same side of the double bond. So I can call these isomer as a cis isomer, right? Cis isomer. Then here, if you are observing here, right? Two hydrogen atoms are the two identical groups. They are on the opposite side, right? Opposite side of the double bond. So I can call these isomers as the trans isomer, right? Trans isomer. So that we can define the geometrical isomers as cis and trans isomers, in which the identical groups, right? Identical groups if the identical groups are on the same side of the double bond, it is called as cis isomers. If it is on the opposite side of the double bond, it will be called as trans isomer, right? Is that clear now, Himanshu? About the geometrical isomerism, that is about the cis-trans isomers. Okay, fine. Now there is some practice questions for you to find out the geometrical isomers. Try along with me. Try to find out the cis-trans isomers of these two compounds. What do you have to do first? Double bond, right? Double bond. Then, in the case of first carbon atom, there will be two different groups, right? One is hydrogen and another one is chlorine. And similarly, second carbon is also having hydrogen and chlorine. So here I am taking hydrogen here. Then it is chlorine, right? Similarly, it is hydrogen. Then it will be chlorine, right? So this is one type of isomerism. Now I am doing the another one, right? I am keeping the first carbon like this. Just changing the configuration of hydrogen and chlorine in the second carbon, right? Okay, it is easy, right? So this is our cis isomer because same identical groups are on the same side. Here it will be the opposite side. This will be the cis-trans isomers of the compound, right? Then you have to find out their IUPAC names also. What will be the IUPAC name? Hi Harshid. IUPAC name, 2 carbon. Yes, 1,2-dichloroethene, right? Because this is a 2 carbon compound containing double bond. So it will be ethene, in which ethene 2 hydrogen atoms are replaced by the 2 chlorine atoms, right? So it will be 1,2-dichloroethene. So in order to explain the geometrical isomerism, you need to give the cis-trans in front of the name, right? So this will be cis-1,2-dichloroethene. This will be trans-1,2-dichloroethene, right? Trans-1,2-dichloroethene. Clear? Then try with the second compound, right? Try with the second compound. I think it is easy to find out their cis-trans isomers, right? So I will be writing here. One it is CH3, another one it is C2H5, right? Ethyl group. What will be their name? What will be their name? Here some of you may make the mistakes while numbering the compound. You may feel like that it will be a 2 carbon compound, right? But you have to find out the longest chain. While numbering here, you may get that there will be 2 carbons, right? So here will be 1, 2, 3, 4, 5, 6, right? So this will be the 6 carbon compound containing double bond. So I can call this as in third position. This is our longest chain. The third position there is a CH3 group, right? So 3,4-dimethyl, right? 3,4-dimethyl hex 3-ene, right? Is that clear about the IUPAC nomenclature? This compound is like this, CH2, CH3, right? Now you may get the idea. First, second, third, fourth, fifth and sixth, right? Then this will be our cis compound, so name should be given as cis 3,4-dimethyl hex 3-ene. Is that clear? Similarly, you can draw the trans structure also. Only difference between the cis and trans is the the identical groups will be in the opposite side, right? Okay, try to find out the trans isomer also. Now let me move to the next topic. About the next question. 4 different compounds are given here. You have to identify the compounds which is showing cis-trans isomerism. Cis-trans isomerism. What will be the answer? Which of the following compounds will show the cis-trans isomerism? Okay, there is one condition to know about the cis-trans isomerism or the geometrical isomerism. I have already mentioned that there will be a restricted rotation, right? Restricted rotation between the carbon-carbon double bond. One more thing or one more condition is that the 2 carbon atom involved in the restricted rotation or in the double bond must attached by the 2 different compounds or 2 different atoms or groups. Clear? Now let me tell you what will be the answer here. 3 and 4, right? So I am taking the double bond here, C double bond C. One is hydrogen, right? Another one is C6H5, right? C6H5. Then in the second one it will be hydrogen, then CH3, right? What is our condition? The two carbon atoms present in the double bond must contain at least 2 different substituents, right? At least 2 different substituents. So this will be our cis one. What will be the trans? You may get the position here, right? Then what about the fourth one? C double bond C. First group it will be CH3, right? Here it will be CH3, then hydrogen. Then here one is chlorine and another one is CH3, right? This is our trans, right? Because CH3, same identical groups are on the opposite side. Now I am drawing the cis isomer here. Keeping the first carbon just like that. Changing the position here. So it will be CH3, Cl, right? So 2 methyl groups, identical groups are on the same side. So it will be cis, right? Clear? So the last 2 compounds will show the cis-trans isomer because they contain, the double bonded carbon contain at least different identical groups, right? Different identical groups. As you are observing here, in the first carbon itself there will be 2 same type of group, right? 2 methyl group. If you are trying to find out the cis-trans isomer, you may fail, right? You are unable to find out the cis-trans isomer. So try to write the isomer of the first 2 compounds also. Then identify whether it is getting cis-trans isomer or not. Clear? Okay, we need to explain more about the preparation of alkenes also. So I will be moving to the next part. Okay, I hope it was clear for everyone about the nomenclature as well as isomerism. That's the first introduction part of alkene. Now let me move to the next part, that is about the preparation of alkenes, right? How we can prepare the alkenes. Okay. Okay, fine. Now let us see the preparation. We have to prepare these alkenes from alkanes, right? Alkanes are our unsaturated hydrocarbons. Then we need to prepare from the alkyl halides, visyl dihalides, and last from alcohols. Let us see one by one. I will be starting along with from alkenes, right? From alkynes. What I have to do, I will just do the reduction, right? Partial reduction. What do you mean by reduction? In terms of hydrogen? Reduction in terms of hydrogen. Addition of hydrogen, right? Addition of hydrogen is known as reduction in terms of classical concept. So I am taking an unsaturated hydrocarbon, right? I am taking an alkane here. This is our alkyne, right? Triple bond compound. I am adding hydrogen, right? Hydrogen. What you are observing? One bond is breaking here. Two hydrogen atoms are attaching to the two different carbons, right? Now you will get the double bonded carbon or alkene. Clear? RCH double bond CH2. So in the case of alkenes also we have seen about the hydrogenation, right? Or the addition of hydrogen in presence of nickel, platinum, palladium, right? There will be a catalyst. But here if you are using nickel, platinum and palladium, this triple bond carbon directly converted into our alkane, single bonded carbon, right? So we need to control the reaction like this. So this is known as the partial reduction of alkenes. Here we are using a catalyst known as Lin-class catalyst. The name of the catalyst is Lin-class catalyst. Now the next question is what do you mean by Lin-class catalyst? Lin-class catalyst. I hope you may have the idea about that. So we can define the Lin-class catalyst as a partially deactivated pelletized charcoal, right? Partially deactivated pelletized charcoal. No need to worry about this long name. We can go through the word by word. Pelletized charcoal, right? Palladium, we already know this is a metal, right? If the palladium which is used in presence of charcoal, this is known as pelletized charcoal, right? Now we are deactivating this pelletized charcoal by using some of the poisons like quinoline or sulfur compounds, right? Quinoline or sulfur compounds. So in general, Lin-class catalyst is known as the palladium supported over barium sulfate, right? Palladium supported over barium sulfate containing sulfur or quinoline. These are act as the poisons in order to deactivate the pelletized charcoal. Is that clear what you mean by Lin-class catalyst? So instead of Lin-class catalyst, you can express this reaction as this type also, right? If you are adding hydrogen in presence of pelletized charcoal, right? Pelletized charcoal in presence of supported with barium sulfate in presence of quinoline, right? This is our Lin-class catalyst. So you will get the alkene product from the alkyne. Clear? Okay, fine. Now, there is an interesting thing you have to keep in mind about the reduction of alkenes. So, we have already seen about the different types of alkenes, right? There will be cis alkenes as well as trans alkenes. So, if I am taking any of the alkyne, how I can observe whether I am getting the cis alkene or trans alkene, right? So, depending upon the catalyst we are using, we can get different types of alkenes. One will be cis, other will be trans. Let us see what are the catalysts we are using. So, as we already seen about the Lin-class catalyst, right? Lin-class catalyst. So, we can say that if you are using Lin-class catalyst, right? Lin-class catalyst, you will get the alkene in the cis form, right? You will get the alkene in the cis form. This is very important in your examination point of view. Most of the repeated questions came from this particular topic. Depending upon the catalyst, how we are producing the cis and trans alkenes. Okay, fine. Then, what is our next condition? We have to prepare trans alkene, right? Trans alkene. So that I am changing the Lin-class catalyst. Then I am using sodium in liquid ammonia, right? Sodium in liquid ammonia. What I am observing? I will get the trans alkene, right? I will get the trans alkene. So, many of the previous year question, you can see that reaction will give like this. You have to identify the reagent, right? You have to identify the catalyst or reagent here. So, this is very important. Okay, I hope it is clear. Now let me move to the next type of preparation of alkene from our alkyl halides, right? Alkyl halides. So this method is known as dehydrohalogenation, which means that we are eliminating the hydrogen halide, right? Hydrogen halide HX from the alkyl halide. Let us see the reaction here. So I am taking the ethyl chloride, right? CH3CH2Cl, ethyl chloride. Here the reagent which is used, or the catalyst which is used here, it is alcoholic KOH, alcoholic potash. Either you can add it as KOH plus alcohol, otherwise it is also written as alcoholic KOH. Heating with alcoholic KOH. What you are observing? One of the chlorine atom, right? One of the chlorine atom and one of the hydrogen atom is removing to form the ethene, right? Here it will be ethene along with KCl and water. Clear? So HCl is removing here. So this is a hydrogen and chlorine is removing from here. So it is known as a dehydrohalogenation process, right? Now I am just expanding the structure here, right? Heating with the alcoholic KOH, the same reaction I am doing. What I am observing here, this is our chlorine, right? This is our chlorine. It is removing from this carbon. Then one of the hydrogen atom from here is removing. If I am giving the name, giving the position here, I can say that chlorine is attached to the first carbon, right? So this will be our alpha carbon. This will be our beta carbon, right? This will be our beta carbon. So here hydrogen atom is leaving from the beta carbon atom, right? So this particular reaction is also known as beta elimination. Clear? You can see this term in your NCERT textbook. Beta elimination. Because hydrogen atom is removing from the beta carbon atom in the alkyl halide. So you are observing CH2 double bond CH2 here. Clear? Now if I am taking another compound here, right? Heating with the alcoholic potash or alcoholic KOH. What will be the possibility of alkenes forming? So, chlorine atom is removing from here. Then there will be two possibilities, right? Either one of the hydrogen can be removed from the first carbon or the third carbon. So I am taking two products here. One it is CH3, CH double bond, CH3. Then another one is CH2 double bond C CH2 CH3, right? So can anyone please say what will be my major product? I have already given two products here, right? This is but2-ene, this is but1-ene. What will be the major product here? Just give me a random guess. Himanshu, which point? Which point I want to repeat? Okay, I think it is about the beta elimination. So, for example, I am explaining here. This is our chlorine group, right, or a halogen group. It is attaching to a carbon that is known as alpha carbon, right? So, these two carbons, it is attached to the another two carbon atoms are known as beta carbons, right? Beta carbons. So, in general, dehydrohalogenation is known as beta elimination, right? So, in beta elimination, there will be possibility of removing hydrogen atom from the beta carbons, right? So, here two possibilities are present. if I am taking this is my first carbon, I can remove hydrogen from the first beta carbon. So I will get the product but1ene, right? Now if I am taking the hydrogen atom from the third beta carbon, right? Third beta carbon, I can get the product of but2ene here, right? So what will be the major product here? So I know that but2ene will be our major product, right? In order to predict the product here, we are explaining the major important rule known as Say-Safe rule. This is also very important. Application of Say-Safe rule is very important. So what we are observing in the case of Say-Safe rule? In case of dehydrohalogenation reaction, right? Dehydrohalogenation reaction, alkenes are forming, right? The hydrogen atom is preferentially eliminated from the adjacent carbon atom with fewer number of hydrogen atoms, right? Okay, I know it will be difficult to read this sentence. Let us see from the example, right? What Say-Safe rule is saying? The hydrogen atom will be removed from the position of carbon which contain less number of hydrogen atom, right? There will be two possibilities. One is CH3 here, one is CH2 here. So, according to Say-Safe rule, he says that hydrogen atom is removed from the carbon atom, the nearest carbon atom having less number of hydrogen atoms. So here it is CH2, right? So the hydrogen atom is going from the CH2 position here. So I can say that but2ene, right? This is the product formed from the second position of beta carbon, right? So I can say that but2ene will be the major compound here. Is that clear? Is that clear? If it is not clear, I can repeat it again. No issues, because this is very important concept about Say-Safe rule. The only thing is that you have to identify the elimination in which hydrogen atom is removed from the carbon atoms where carbon atom is containing lesser number of hydrogen atoms, right? Okay, I hope it is clear. Now let me move to the next preparation method of alkenes from the vicinal dihalides. What do you mean by vicinal dihalides? Okay, vicinal means nearby, right, or aspas mein. Or vicinal is known as nearby compound. So for example, if I am taking these compound, right, these are our nearby carbon. Two halides groups, right? Two halogen atoms are present in the nearby carbon atoms, two adjacent carbon atoms. So I can call this as a vicinal dihalide, which means two halogen groups are present. So this will be vicinal dibromide. So in case of vicinal dihalide, we need to do the dehalogenation, which means halogen groups are eliminating here. What is the reactant using here? It will be zinc, right? It will be zinc. So vicinal dibromide, I am treating with zinc. I will get the alkene here, right? Alkene here by removing the two Br molecules with the Zn as Zn-Br2. Is that clear? Okay, this is the simplest type of reaction in which we can prepare alkenes from the vicinal dihalides. We need to remember about the metal used here. It will be zinc. Now the last type of method of preparation of alkene is the preparation from alcohols, right? You may have idea about the alcohols. The compounds which contain OH group as the functional group is known as alcohols, right? Alcohols. So let us do the acidic dehydration. What do you mean by dehydration? Hydration means water, right? If you are removing water, it will be known as dehydration. This process will be happen in presence of acid only, right? Acid only. Therefore, this method is known as acidic dehydration of alcohols. Acidic dehydration of alcohols. So, for example, I am taking ethanol here, right? Ethanol. What is my reactant? Concentrated sulfuric acid, right? I am heating with concentrated sulfuric acid. Heating with concentrated sulfuric acid. I will get the CH2CH, right? Ethene molecule here. Here also you can say that it will be beta elimination, right? Beta elimination. So OH group, right? If any of the functional group is attached to the carbon, that particular carbon is known as alpha carbon, right? This will be our alpha carbon, right? Then the nearby carbon will be beta carbon. So what you are observing here, in order to understand, I am just changing the position of OH. These are same, right? So you can observe here, these H and OH will combine to form water molecule. By this removal of this water molecule, you will get the product as CH2 double bond CH2, right? CH2 double bond CH2. So here also the hydrogen atom is removing from the beta position of carbon. So this particular reaction is also known as beta elimination, right? Clear? Beta elimination. Okay, fine. Now, I think you must have studied about the tertiary, secondary and primary alcohols, right? Tertiary, secondary, primary alcohols. So we need to remember the rate of reaction or the ease of dehydration of alcohols. It will be starting from tertiary, secondary, then primary, right? Okay, you may get an idea about the mechanism in case of alcohols chapter, right? There will be a chapter in your grade 12, alcohols, phenols and ether. You will get the idea about the mechanism here. I can just give a brief idea that in this case of dehydration, there will be a reaction intermediate is forming, right? It will be carbocation. So based on the stability of carbocation, we can say the ease of dehydration here, because tertiary carbocation is more stable than secondary than primary. Clear? Now, again, if I am taking another compound here, right? Here I am taking I am getting two different products, right? I am getting two different products, but2-ol. Okay, you need to mention the reagent here. It will be concentrated sulfuric acid by heating, right? To give you reagent is very important case of these particular reactions. So, what is the thing we must observe here? How we can predict the major product here? We have already studied about some rules, right? In here also we can apply the Zaitsev rule, right? Zaitsev rule. So what will be the major product? Definitely OH will be removing, right? So there will be two beta positions. There will be two beta positions. One is here and another one is here, right? So according to Zaitsev rule, it is saying that the hydrogen will be removing from the carbon that contain lesser number of hydrogens, right? Yes, lesser number of hydrogen atoms, right? So here it is CH2, here it is CH3. So I can say that product will be formed by releasing hydrogen from this beta carbon, right? This beta carbon. So I can say that 2-butene is the major product here. Is that clear? This is the application of Zaitsev rule. By experiment also you can say that 80% of 2-butene will be present and 20% of 1-butene will be present. So that 2-butene will be the major product. Okay, now let us quickly practice some questions. Here is the first question. The major product in the acid catalyzed dehydration of 2-pentanol. Acid catalyzed dehydration of 2-pentanol. This is 2-pentanol, right? So OH will be going from here. This is one of the beta and this is the one of the beta. According to Seitz's rule, lesser number of hydrogen is present in between these carbon atoms. So I can form the product like this: CH3, CH double bond, CH, CH2, CH3, right? What will be the name of this compound? This is a compound containing 5 carbon atoms. So word root will be pent. Position of double bond will be at the second position, right? So it will be pen2E, which means option 2 will be the correct answer. Then here is the next question. CH3, CHBr, CH2Br, alcoholic KOH, right? Alcoholic KH. What is the reaction happening here? Alcoholic potash. Dehydrohalogenation, right? Dehydrohalogenation. Similarly, according to Seitz's rule, there is only one equivalent, right? So here you can observe there will be 2 Br group. So here it will be observing that one bromine is eliminating from here. Then this is our alpha, this is our beta. Alpha and beta, one bromine is eliminating from here, one hydrogen atom is eliminating from here. So you will get the product CH3, CH double bond, CHBr, right? Which means option 1 will be the correct answer. Option 1, right? Okay, here we are getting only one equivalent of alcoholic KOH, right? One equivalent of alcoholic KOH. Okay, fine. Okay, give me the answer very fast. What is the product of this reaction? This is hydrogenation, right? We are adding hydrogen in presence of sodium in liquid ammonia. Focus on the reagent only. Sodium in liquid ammonia. What will be the product? As we already know, this will be the product forming alkene, right? Whether it is cis or trans. Trans, right? Because we are using sodium in liquid ammonia. If you are using sodium in liquid ammonia, it will be forming trans alkene. Instead of sodium in liquid ammonia, if you are using Lindglass catalyst, you will get the cis alkene. Clear? Which means option 2 will be the correct answer. Yes, option 2 will be the correct answer. Okay, here is the next question. This is based on the previous class also about alkane and alkene combined part. So I will be just quickly give the answer here. This is our alkyl halide, right? Alkyl halide, I am doing the reduction in process of zinc copper coupled, right? What you will get? We will get the corresponding alkane, that is C2H6, right? Then here, if you are doing alcoholic KOH reaction, it will happening dehydrohalogenation, right? Dehydrohalogenation. So you will get the alkene group here, it will be C2H4, right? So product A will be C2H6, product B will be C2H4, which means option 3 will be the correct answer. Okay, here is the last question. Based on the idea about the IUPAC nomenclature of compound, you have to identify the number of sigma and pi bonds in this particular compound. IUPAC name is given here. First, you have to draw the complete structure, right? You have to draw the complete structure. In third and fourth position, there will be 2 methyl group, right? Then in the third position, there will be triple bond, right? So I am taking here triple bond. Now you have to balance the valency of carbon here. It will be CH3, CH2, okay, it will be CH only, right? 3,4-dimethyl hept 3 in, right? Right? This is our structural formula for the 3,4-dimethyl hept 3. So, in order to find out the number of sigma and pi bonds, you must have an idea about that. If you are taking double bond, right? If you are taking double bond, one of the double bond it will be pi bond. This will be one pi bond. This will be one sigma bond, right? So, you need to numbering the total number of sigma bonds here. In case of one carbon atom, there will be 3 hydrogen sigma bond, right? So, in total it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, right? In total of, okay, read the structure carefully. While finding, you will get 26 sigma bonds, right? 26 sigma bonds and 1 pi bonds. You need to consider the all CH sigma bonds also, right? Okay, that's all about from my side for today. So far we have discussed about the nomenclature as well as isomerism of alkenes, right? And we have studied about the preparation of some alkenes also. So there is a gentle reminder about the AATS. This is the right time to take the mock test because JEE Main session 2 is coming on. So link will be provided in the description. You can enroll fast. So in the next class, I will be coming back with the alkenes, physical and chemical properties of alkenes, along with some important name reactions. So I hope it was clear for everyone. For today, I will be winding up the session for today. Anyway, thank you so much all of you. Bye-bye and take care. Keep on revising the questions, right? Okay, fine. Thank you so much. Bye-bye.